All right, good morning, everybody. A little bit bad timing there on my part, but all right, here we go. So electrical work. This lesson here is regarding electrical work, and basically anytime you plug something into an outlet, to give it, charge your phone or whatever, there's electrical work that's happening while the phone's charging up. Now, formula, W equals delta V times Q. Notice that I do have a box around the delta V. Delta is a Greek letter. It means change, all right, symbolized by your basic equilateral triangle. Now, I have a box around this because I want you to understand that delta V is one variable. The voltage is changing, and so as opposed to the voltage being constant, the voltage is changing. So treat this as one variable. It's not delta times V. It's just letting you know, hey, the voltage is changing. Then you have Q here. Q represents electrical charge measured in units called coulombs. And you take the voltage difference times the electrical charge, and you get the amount of electrical work. Electrical work is measured in joules. Now, here's an example problem here. Let's say we got 12 volts moving 6,000 charges, or 6,000 coulombs, excuse me. Just multiply two numbers together. 12 times 6,000 is 72,000. That's all you got to do. Sometimes you are provided with the amount of electrical work, and you need to solve for either delta V or the number of coulombs. The number of coulombs will always be a nice even 4 or 5 digit number, 6,000, 14,000, whatever. All right, it won't be anything crazy, like 5,280. All right, it won't be anything like that. So you just divide it out here, you get 5 volts. Now, so with electrical work, that's pretty much all you need to do. Either multiply the voltage difference times the charge, or divide work by either the coulombs or divide it by the voltage, just depending on what's provided in the problem. But at any rate, that's all there really is to do with that. So, so you have that worksheet, or that's part of the assignment. Now we're going to move over here, and you've already seen this, but you haven't seen this. So we're talking about electrical efficiency. What it does is compares the amount of electrical work the system does, as it said. Whoops, still getting used to this device here. The amount of work that the system does with how much electrical work is put into the system. Now, for a lot of times, these efficiency problems, they're basically percentages. Your answer comes out to be a percentage. So, and we'll get to this example here in a second. But it might be something like, 120 divided by 600. All right. So it's like this. You put in 120 joules. I'm sorry. You put in 600 joules. All right. You put in 600 joules, and the amount of work that the system does is 120 joules. So what's that percentage? Well, when you divide 120 by 600 on your calculator, you're going to get this. All right. The thing is, with efficiency problems, you need to make sure that the answer is expressed as a percentage. So 2.2 is 20%. How do you get from here to here? Move the decimal point over 2 places to the right, or hit times 100 on your calculator, and you'll get the same result. All right, but that's just 20%. Now, in some cases, you are provided with some information where you know the input work, but you don't quite know the output work. We really didn't get a chance to talk about this, but work in itself is equal to force times distance. So you know the force here is 700 newtons. You know the distance is 6 meters. So what you're going to do first here is multiply 700 times 6, which is 4,200. All right, this is your output work. All right, and you're going to know that just by reading the problem, because you're going to say, oh yeah, okay, he told us what the input work is, but I got to figure out output work. So what do? Again, force times distance. All right, and we're going to divide that by 5,300, and we're going to get, let me grab my calculator. When you divide everything out or get the percentage, it's going to be 79%. All right, 79% efficient. So this problem was basically a two-part problem. Where some people run into trouble is they might do this. They might flip it around and say, okay, 5,300 divided by 4,200. Well, when you do that, let me grab the calculator here because I don't know this off the top of my head. Maybe you do. I don't know. But you do 5,300 divided by 4,200. You get 1.26. All right? 1.26. All right, which when you express that as a percent is 126%. Now, you might have seen the commercial on the radio about Chase, I think it's the Chase Bank, or Fifth Third. Fifth Third, that's what it is. And they say, oh, we're 166 efficient, percent, whatever. No, you can't do that, all right? This doesn't work here. If you only have 4,200 joules of work going into the system, you cannot get more out of it than what you put into it. All right, this doesn't work. So if you see numbers like this on your calculator, don't just blindly, oh, Mr. Guerra, the efficiency is 126%. No, time out. What you need to do in all likelihood is just flip the fraction around. All right, so that your efficiency is always less than 1. All right, your efficiency has to be less than 1 in all cases. Not less than 1, but like when you are, when you type in your answer, you type in the numbers and divide them out. The number that comes up on display on your calculator should be less than 1, 0.798675,309, whatever. Then you just make that a percentage by hitting times 100. All right, so all your answers will be in the form of a percentage as long as you are calculating the efficiency. Now, that being said, in some cases, you will be provided with the, here we go, you will be provided with the percentage already, the efficiency. So let's say the efficiency is 67%. You don't know input work, but you do know the output work to be something like 2,021 joules. Wonder where I got that number from, right? All right, so first thing you do here, make this a decimal. How do you do that? Here's a decimal point here, move it 2 places over to the left. So this becomes 0.67 equals 2,021 over x. Now, in this case, what do you want to do here? I would put this over 1 and then cross multiply and divide. Invariably, some of you will say, ooh, Mr. Derrick, I multiply here and I get 1,354.07. Well, in no way is 2021 divided by 1,354.07 equal to something less than 1. So you want to make sure you cross multiply and divide here. So, do the butterfly method if you know what that is. That's not the best butterfly I've ever drawn, but hopefully you get the idea. 0.67x equals 2021. Divide by, 0.67. So 2021 divided by 0.67 gives you an answer of 3,016.42 or so joules. All right, so with certain problems like that, you're going to want to, you might have to, set up a proportion here, or maybe you might not need to. It just depends on what your comfort level is with a little bit of algebra here. So in any case, make sure you always do output over input work, and if your if your answer on your calculator comes out to be something like 1.25 whatever, chances are you need to flip that fraction around so that your answer is less than 1, right, when you're calculating efficiency. All right, so the assignment was posted a couple hours ago now, several hours ago. And, as always, if you have questions, let me know. I'm more than happy to give you a hand. Looks like we're still recording. Yeah. Okay, so